Hello everybody, I am Dr. Umer Mehmood, serving as an assistant professor at the Polymer and Process Engineering Department of UET Lahore. My area of research is thin film solar cells. Currently, I am working on the development of Polymer-Gel-Electrolytes for dye-sensitized solar cell application. This research project is funded by HEC Pakistan under the head of CPEG. It is joint project of UET Lahore and Harbin Institute of Technology, China. My co-PI in this project is Professor Yong, belongs to Harbin Institute of Technology. The outline of my presentation would be introduction, major advantages of DSSC, structure and working mechanism, and lastly, I will briefly explain my research work. Solar radiation, basically the sun is made up of about 80% hydrogen and 20% helium. Its radiant power comes from nuclear fusion process. Each second, more than 400 million tons of matter are converted into energy within the sun core, producing neutrons and solar radiations. As you can see in the figure, the solar spectrum covers the near ultraviolet, visible region and infrared spectrum. Specifically, 5% is UV radiation, 43% visible radiation and 52% infrared radiation. Each of these bands has a different impact on the environment. The amount and intensity of solar radiation that a body receives depends on a variety of factors. These factors include latitude, season, time of day, cloud cover, and altitude. Not all radiations emitted from the sun reaches the Earth's surfaces. Much of it is absorbed, reflected, or scattered in the atmosphere. Potential energy is considered as a potential source of energy. As you know, the world power consumption, which is 13 terawatts currently, is expected to reach about 23 terawatt in 2050. So solar power is the key to a clean energy future. Every day the sun gives off far more energy than we need to power everything on the earth. It is renewable source of energy. Solar cell produce electricity by transforming the continuous flow of energy from the sun to electricity. Also, it is combustion free process. No harmful emissions are released into the air when electricity is produced by solar panels. As you know, solar cells are devices that use the photovoltaic effect to convert the energy of light directly into the electricity, producing no electric charges that can move freely in the semiconductors. The process was discovered as early as 1839, but the first solar cell was introduced by Bell Executive in 1954. Unlike batteries or fuel cells, solar cells do not utilize chemical reactions or require fuel to produce electric power. And unlike electric generators, they do not have any moving parts. The types of photovoltaic cell, basically solar cells, are generally classified into four generations, depending on the time and category of materials which are used for their fabrication. The most common solar cells available in the market are the first generation solar cell, which comprises single and multicrystalline silicon. Second generation solar cell were introduced as a response to high material usage and cost of silicon solar cell. To reduce the material usage, the maximum film thickness for this generation was brought down to a few nanometers to tens of micrometers. Meanwhile, many researchers have attempted a light management concept using dye-sensitized solar cell, perovskites, organic solar cell, quantum dot solar cell, and nanostructuring and as well as nanopatterning. Um, Still, the silicon-based solar cells are most demanding in the market of photovoltaic cells due to high efficiency of approximately 15 to 20%. However, their energy-intensive processing, rigidity, reduction in the efficiency at higher temperatures, and requirement of extremely pure silicon are the prominent concerns in silicon solar cells. Uh, the presence of these concerns stimulated the researchers to investigate the novel organic materials for photovoltaic applications. Similarly, perovskite solar cell give the highest power conversion efficiency. The most recently recorded power conversion efficiency of perovskite is 23% in the single junction layout. But perovskite solar cells are least stable against humidity and oxygen. And also the complexity in their fabrication process provides significant complications in their commercializations. Similarly, polymer-based solar cells also involve a complex process for their fabrications and are less efficient. However, on the other hand, uh, DSSC are much easier to fabricate and their efficiency has improved from 7% to 14%. So DSSC possess an efficient power output in the entire range of light spectrum, including LED or indoor fluorescent. Even they can work efficiently in the condition of diffuse or dim sunlight, whereas silicon-based solar cells are not as efficient and perform rather poorly under these lighting conditions. Uh, It was invented by Michael Gritzel in 1991. At that time, its efficiency was only 7%. So his research was published in Nature. So that was the first paper on DSSC. So what are the major application of DSSC? DSSC found to be very useful, particularly in the applications of wireless sensors networks, sports and medical devices, cameras, security sensors, and wearable electronics. A substantial amount of these smart electronics and wireless sensor networks are included in the Internet of Things environment that promises the vast network of connected devices gathering the big data on which our production, medical, infrastructure, and industries will be examined and optimized. These sensor devices require exceptionally low power input of their application, and it will be a remarkable if they could be driven by low light or indoor power gathering system. Thus, DSSC can be a potential candidates for IoT's applications. What is the latest trend in the market? Many companies are fabricating DSSC globally due to increase in the market potential that is estimated to grow 12.4% from 2015 to 2022. DSSC were worth 49.6 million USD in 2014, and it is estimated to be captured 130 million USD by 2022. The emergence of DSSC in the photovoltaic market is huge as companies like Dysol has officially started its new manufacturing facilities in Australia on October 2008. Later on, it has announced a partnership with Tata Steel for large-scale manufacturing and development of building integrated photovoltaics. Another companies, if you see 3G cell uh, and G cell, both belong to Israel, are fabricating DSSC modules for wireless electronics. Um, as you can see, uh, DSSC is traditionally fabricated using two sheets of highly conductive and transparent materials. Transparent glass coated with indium tin oxide and fluorine doped tin oxide act as a substrate. However, FTO is preferred because its sheet resistance remains constant upon sintering. Similarly, semiconductor metal oxides are used as a photoanodes of DSSC. Its function is to absorb dye and transform electrons to the external circuit. So titanium oxide is regarded as an excellent semiconductor due to good photocorrosion resistance and substantial electronic properties. The major component of DSSC is the dye. That is the third component. Its function is to absorb light and injects electron to the conjunction band of the semiconductor. An efficient photosensitizer must absorb sunlight in the visible region, that is from 400 to 700 nanometer. Similarly, the fourth major component of uh, cell is electrolyte. The function of the electrolyte is to regenerate the dye after it injects electron into the conduction band of semiconductor. However, the long-term stability of DSSC depends on the properties of electrolyte. Similarly, another important component of the DSSC is the catalyst. Its function is to accelerate the reduction reaction at the counter electrode for the regeneration of electrolyte. An optimal counter electrode should possess good catalytic activity and high conductivity. So in this regard, platinum is considered as a best catalyst properties for DSSC application, but it is an expensive noble metal, show poor corrosion resistance against electrolyte. So alternate materials like carbon allotropes and conductive polymers can also be utilized for the applications of DSSC. So what is the working mechanism of DSSC? As you can see in the figure, dye molecules are attached to the metal oxide semiconductor through a covalent bond. The adsorbed dye absorbs solar radiation and electrons in the dye become excited. So electrons tend to move from low energy level to high energy level. The highest occupied molecular orbital is considered as low energy orbital, while the lowest unoccupied molecular orbital is regarded as the high energy orbital. The electrons are then infused into the conduction band of the metal oxide semiconductor. They pass through a mesoporous thin film of semiconductor and finally collect at conductive substrates. So electrons from photoanode then reach at a counter electrode through an external circuit, as you can see in the figure. Meanwhile, electrolytes regenerate the oxidized dye and then diffuse towards the counter electrode. At counter electrode, a reduction reaction takes place and the electrolyte is regenerated here. So in this way, the working cycle of DSSE is completed. So what are the major challenges in the commercialization of DSSC? So there are three major challenges in the commercialization of DSSC. These include stability, replacement of electrolytes with gels or solid state polymers um, can enhance the efficient stability of solar cell. Similarly, the other challenge is efficiency. uh, how to increase the efficiency? Efficiency can be increased by modify the photoanode to enhance the light scattering efficiency and charge collection efficiency. Similarly, cost is the major factor. So replacement of expensive components such as platinum with conductive polymer can reduce the cost of the device. So the primary focus of our research is to enhance the stability of DSSC. As we discussed in some previous slides, the long-term stability of dye-sensitized solar cell depends on the property of electrolyte. Therefore, the electrolyte must have the following characteristics. Uh, First one is as a high electrical conductivity and moderate viscosity for faster diffusion of electrons. It should not cause desorption of dye from the semiconductor surface, and also it should not absorb light in the visible region. So electrolytes for DSSC are classified into two types, and the first one is liquid electrolyte, and the last one is solid state electrolytes or polymer gel electrolytes. Liquid electrolytes basically consist of redox, couple, organic solvent, and additives. However, high evaporation rate and leakage limit the long-term stability of DSSC based on liquid electrolyte. So, in order to improve the performance, stability, solid states electrolyte have been developed. Uh, Polymer gel electrolytes contains a polymer, solvents, and salt. Ionic conductivity of polymer electrolytes depend on various factors such as molecular weight of the polymer. Higher the molecular weight, lower will be the conductivity. Similarly, the concentration of polymer. Concentration of polymer inversely affect the conductivity of electrolyte. Similarly, the concentration of salt enhances the conductivity of electrolyte. As a whole, polymer electrolytes can be divided into two categories. The first one is thermoplastic polymer electrolytes. Thermoplastics include polyvinylidene fluoride or PVDF, and thermosetting polymer electrolytes. These include polyacrylic acids and polyethylene glycol. Currently, the main objective of our research work is to develop polymer gel electrolytes using conductive polymers and fluorinated polymers. In case of conductive polymers, we use polyaniline as a host material, while in case of fluorinated polymers, we are specifically using polyvinylidene fluoride or PVDF. First, I will briefly explain the synthesis of PANI multi-wall carbon nanotubes based polymer gel electrolytes and its effect on the stability and the photovoltaic performance of DSSC. So, uh, the first is synthesis of nanocomposites that is based on polyaniline and multi-wall carbon nanotubes. As the first step is as ammonium persulfate was dissolved in HCl to get a uniform solution. Secondly, the acidic solution of aniline was prepared by dissolving 5 ml of aniline in HCl. Next, the precise amount of multi-wall carbon nanotube in a 1 molar solution of HCl was dispersed by sonication for 30 to 40 minutes. Then these three solutions were mixed and then stirred for 24 hours at 0 centigrade. Initially, the prepared solution was filtered, washed and dried at 40 centigrades for 24 hours. The samples were prepared in a similar way, just by varying the amount of multi-wall carbon nanotubes. Similarly, the next step is how to synthesize the polymer gel electrolytes based on nanocomposite. The synthesized nanocomposite were used as a base material to prepare polymer electrolyte. In the first step, ethylene carbonate and propylene carbonate were mixed in equal parts at 45 centigrades for 10 minutes with stirring of 300 rpm. Then 0.1 gram of potassium iodide salt was added to the above mixture and stirred at 80 centigrade for 60 to 80 minutes. After that, a fixed amount of nanocomposite was added at 100 centigrade with a constant stirring for 2 hours to achieve a homogeneous solution. Finally, iodine was added to the above solution and the whole mixture was kept at a constant speed for 15 to 20 minutes. Uh, the other electrolytes with different salt concentration were prepared in the similar way. Now, how to fabricate the solar cells? The first step is titanium coated glass were heated at 450 centigrades for 30 minutes. Then coated substrates were dipped in a zero point 0.5 millimole dye solution for 24 hours. So after complete sensitization, photoanodes were washed with methanol to remove the free dye. Similarly, you see on the figure, platinum coated substrates were annealed at 450 centigrade for 50 minutes to make the counter electrode. After fabrication of both electrodes, prepared solid-state electrolytes or polymer-gel electrolytes was deposited on the photoanode. Then it was heated for 50 to 60 minutes at 50 centigrades. And both electrodes were then joined together by superglue or epoxy based adhesive. So this is the fabrication of solar cell. Uh, The morphological specific crystal structure and coordination between the ingredients of composites have been investigated by scanning electron microscopy, X-ray diffraction, and Fourier transform infrared spectroscopy analysis respectively. Whereas the performance of electrolytes were characterized by their ionic conductivity. Similarly, the photovoltaic performance of fabricated cells was evaluated by current voltage characteristics. So the Fourier transform infrared spectroscopy, you see the figure, the spectrum of PANI or polyaniline, a peak at higher wave numbers of 385 is accredited to the stretching of the NH group. Similarly, the bands at 2816 are due to the unbalanced CH expansions of the aromatic ring, while peaks at 1565 corresponding to the C double bond stretching. Uh, Thus, the characteristics peaks at 1141 and 8813 are assigned to in-plane and out-plane bending vibration of aromatic CH respectively. Similarly, the OH stretching vibration of the carboxylic group in the multi-wall CNTs shows a peak at 3460. The sp3ch stretching of the benzene ring is represented by broad peaks at 2815, 2879, and 2953. While the band at 1602 and 1375 is assigned to C double bond O stretching vibration and C single bond group. If you see the spectrum of nanocomposites, uh, peaks at 3138 and 3351 are attributed to CH and OH bond respectively. The shifting of peaks position in the spectrum of composites was observed. These shifts in the wave number after mixing of CNTs in PANI confirm the conformation of composites between both constituents. Similarly, the SEM analysis, you see the figure A, the flakes of pristine PANI polymerized by in situ polymerization uh, are presented in figure A. It can also be seen in figure B that a nanocomposites containing 4 to 8% of multi-wall carbon nanotubes show a good dispersion. The dispersion of multi-wall carbon nanotubes in composite is responsible for the better adhesion as well as continuous morphology of nanocomposites. Similarly, the good contact between constituents of nanocomposite provides an effective path for the electron flow. However, agglomerates of CNTs can be observed at higher CNTs contents at 6% weight percent and 8 weight percent, as you can see in the figure C and D. The agglomerates formations degrades the continuous morphology as well as the adhesion between the components of nanocomposites. The low adhesion and disjointed path resist the flow of electron, and thus poor conductivity of the composites. So X-ray diffractions, and as you can see, figure demonstrates the XRD patterns of pristine penny and nano composites having 2 weight percent, 4 weight percent, 6 weight percent, and 7 weight percent of CNTs. Uh, Pristine penny shows a sharp peak at if you see 2 theta is equal to 25 degree and 3 minor peaks at 20.62 and 14 and 8.9 degree. These characteristics peaks are attributed to the periodicity parallel and perpendicular to the chains of the polymer. The intensity of these peaks is comparatively high compared to pristine penny, owing to structural ordering of the penny on multi-wall carbon nanotube surfaces. So it also confirms the adhesion between penny and multi-wall carbon nanotubes as confirmed by SEM images. Similarly, sharp peaks at 25 degree and 26 degree have also been observed for 4%, 6%, and 7 weight percent multi-wall carbon nanotube composites. The minor broadening peaks of composites could be attributed to the formation of nanocomposites. So the polymer gel electrolytes can be characterized by their ionic conductivity. So the figure shows that the ionic conductivity increases with CNT contents in the composites. So the nanocomposites show higher conductivity compared to pristine penny. So it is because penny possess an interstitial structure and electrons may lose their energy in gaps. So in order to improve the morphology or structure, aniline is in situ polymerized with multi-wall carbon nanotubes. The one-dimensional structure of multi-wall carbon nanotubes may fill the empty spaces and provide an effective path for the movement of electrons. Thus, 4 weight percent composite based electrolytes show higher conductivity value compared to other electrolytes. But conductivity falls to low value with the further increase of CNT contents in the composites. It may be due to agglomerates formation at higher CNT contents. Similarly, it shows that salt concentration also affect the conductivity of electrolytes. It increases with increasing salt contents and then decreases with further increase of concentration of salt. The high conductivity value you see on the figure, that is 197 uh, microsiemens per centimeter for composites containing 4 weight percent CNT at zero point 0.5 gram of salt concentration. So thus the combined effect of CNT and salt increases the overall conductivity of the electrolyte system. The current voltage setup was used to investigate the photovoltaic performance of solid state DSSC under the light intensity of 100 milliwatt per centimeter square. So maximum current density, short circuit current density, maximum voltage, and open circuit voltage were calculated from JV curves, while the fill factor and efficiencies were computed using the following relations. That is, fill factor is equal to V max into J max divided by VOC into JSC. So efficiency is equal to VOC multiplied by JSC divided by power input into fill factor. So the as you can see in the table, the calculated photovoltaic parameters of solar cells. So these results demonstrate that efficiency and fill factor both depend on the current and voltage values of the fabricated cell. However, the tabulated results show that VOC or open circuit voltage approximately remains constant for each cell. It is evident from the results that the conductivity pattern directly matches with the current density of DSSC. As discussed in the conductivity section, the synergistic effect of CNTs and salt increases the conductivity of the electrolyte system. Thus, the current density increases with CNTs and salt concentration. The solar cells fabricated with optimized quasi-solid state electrolyte or polymer gel electrolyte revealed superior performance, as you can see in the table. However, it also shows that the performance of the cells goes down at higher CNT and salt concentration. So what could be the reason? At higher CNT contents, agglomerates form, act as a trapping sites and provide a hindrance to the flow of electrons. Similarly, salt remains undissolved at a higher concentration, providing resistance in the flow of electron. Thus, the efficiency or performance of cell drops at higher concentration. If you see the table, that fill factor increases with CNT contents. Higher the fill factor, more will be the forward flow of electrons and vice versa. So low fill factor stimulates the breakdown recombination reaction within the cell. So efficiency of the cell becomes low at higher CNT contents or at higher salt contents. Uh, This table shows that the liquid electrolyte based DSSC shows higher efficiency of 4.95% at the start, which is superior to the device fabricated with polymer gel electrolytes. However, after a week, the efficiency of polymer gel electrolytes based DSSC remains stable, while the efficiency of conventional DSSC approaches to zero. The stability of DSSC is an important aspect of their commercialization. Thus, the fabrication of DSSC using polymer gel electrolyte is an easy way to enhance the stability of DSSC. Uh, this research work has been published in the International Journal of Energy Research, having impact factor 5.167. So this is the outcome of our latest research. Similarly, there's a case study too. We also developed polymer gel electrolytes using fluorinated polymers. These polymers have advantages over other polymers as they show strong degradation resistance against ultraviolet light. So the most commonly used fluorinated polymer is PVDF or polyvinylidene fluoride. The other materials used in this research were potassium iodide, which act as a salt and increases the conductivity of the system. Uh, Similarly, ethylene carbonate is used as a solvent. Propylene carbonate is used as a plasticizer and keeps the viscosity of the system moderate. Uh, while the iodine is used as a reducing agent in this research. So similarly, the synthesis of gel electrolyte that is very simple. The ethylene carbonate and propylene carbonate were stirred together for 30 minutes. The precise amount of potassium iodide was added into the EC and PC solution. The whole mixture was stirred at 80 centigrade for 60 minutes. Subsequently, PVDF was added into the above salt solution and the mixture was again stirred at 180 centigrade until the gelation occurred within 15 minutes. Finally, iodine was added with continuous stirring at a temperature of 120 centigrade. The same methodology was used to prepare the other electrolyte samples, with the only difference being the amount of the salt used. Similarly, this is the conductivity curve. As you can see in the figure, the conductivity of polymer gel electrolytes increases with increasing the salt concentration. It shows the highest conductivity value of 300 microsiemens per centimeter at 0.09 gram of salt. However, it can also be observed that the conductivity decreases at higher salt concentration due to ion cluster formation. Saturated solution shows maximum conductivity as the concentration of salt further increases from the saturation limit. It will not dissolve and remain as a cluster, which reduces the ionic conductivity of the solution. Similarly, the photovoltaic performance and stability of DSSC. If you see the table, this table shows that the conventional DSSC or liquid electrolyte based DSSC possess higher efficiency as compared to polymer gel electrolyte based DSSC. But it can also be seen in the figure B that the efficiency of the conventional DSSC decreases with the passage of time. However, the performance of polymer gel electrolyte based DSSC remains stable after 40 days. So this is the major advantage of polymer based electrolytes. So this over research has been published in IEEE Journal of Photovoltaics. Its impact factor is 3.789. So this is the second outcome of over research works. Thank you so much for listening this presentation. So questions are welcome.